Welcome back, and today we're going to start section 4 of chapter 7, and we're going to talk about linear inequalities in two variables. So we're going to start with going from equations. So up to this point we've been dealing with linear functions, linear equations, and now we're going to deal with linear inequalities. So it's going to be one more step on how we graph these or how we analyze these. And so we're going to talk about how to graph a linear inequality in two variables. We're also going to talk about how to use mathematical models involving linear inequalities, and also graphing a system of linear inequalities. Okay. And so again, we're going to change the symbol from equals to either less than, greater than or equal to, or less than or equal to, one of those four symbols. And this makes it into a linear inequality in two variables versus an equality or an equation. Okay, so for example, we have the inequality that x plus y is less than 2. So all values of x and y that make this true is going to be a solution to this inequality. All ordered pairs x and y that make this inequality true is going to be a solution. Okay, so very similar to what we talked about with equations. So we're looking for ordered pairs that will make the inequality true. Okay, if it's true, then it's a solution. If it's not true, then it's not a solution. That simple. Now, the graph of inequality is going to be the set of all points whose coordinates satisfy that inequality. Now, if the graph of an equation was a line, okay, sorry about that. That's if you're hearing my son in the background, he's making a little bit of noise. Okay, so where was I? The graph of an inequality in two variables is the set of all points in the coordinate system, all coordinates that satisfy that inequality. So again, if we talked about the equation of a line, it was all the points on the graph. It was all the points on the line. Well, in this case, it may be all the points on the line, and then everything, all the points to one side of the line. So we're going to look at like a half plane, but it may or may not include the line. That's where the equals, that's where the less than versus less than or equal to come in. Okay, so it's going to be a little bit more involved in graphing these. So here are the steps. What we're going to do is we're going to temporarily replace the inequality sign with an equal sign, because we're going to graph the line first, because that's going to be the starting point. That's going to be part of the solution possibly. Okay, so that now if there's an equal sign, if it's less than or equal to or greater than or equal to, then we're going to draw a solid line for the original equality, okay, for the line. If it's a strictly less than or greater than symbol, then it's going to be a dashed line, which means that the line is not included in the solution set. Okay? If it's a solid line, it's included in the solution set. If it's a dashed line, then it's not included. How do we know if it's included or not? Whether the inequality has an equal sign with it or not. Okay? So here would be solid line. These would tell us a dashed line. Then you've got to choose a test point, because the line that we just drew in number 1 splits the plane into two halves, what we call half planes. So the solution set is either going to be on one side of the half plane, or excuse me, one side of the plane of the line, or the other side of the line, but it cannot be both. So that's where the test point comes in. So what we're going to do is we're going to pick a point on one side of the line. And a good one to start with is always the origin, unless, of course, the line goes through the origin. In that case, we'll just have to pick a different point. But what you want to do is you want to pick a point, it doesn't matter which point, on one side of the line. And what you're going to do is you're going to plug that into the original inequality. And you're going to find out whether that ordered pair you chose, that point you chose, gives you a true statement or a false statement. If it gives you a true statement, then guess what? All of the points on the same side of the line as your test point is the solution. If it's false, if it gives you a false result, then that means all of the points on the other side of the line, in the other half plane, are your solution set. And it's that easy. And that's it. So in this case here, let's look at this. So we want to graph the solution set for this inequality. So step one, we're going to write it as an equation. So we're going to change it to an equal sign, and we're going to solve for the line. And now since it has an equal sign, it's going to be a solid line. And so we're going to plot this line. So we're going to use the intercept method. So we find the x-intercept of 5, 0, right? So we plug in 0 for y. And we find the y-intercept here, which is 0, -3. And we find the graph of the line. And so we get this. So there's the line. Now, notice that the origin is over here. So again, easy point to use. It's very easy because it just makes everything go to 0. So if we plug in 0, 0, we get what? We get 0 here, and we get 0 here. And so we get 0. And so in this case, we get 0 is greater than or equal to 15. Well, is that true? Well, of course not. That's false. So that means all the points on this side of the line are the solution. And all the points on this side of the line are not. So the solution set is going to be all of this shaded region. Okay? And so what we do is we shade in that side of the line. So this would be how we would graph the solution. So we have a solid line that represents the border, and everything on the line is also a solution. And you could test a point. You could test one. Pick one of the intercepts. It will work, right? And then you shade in everything to below the line. Okay? Now, if we look at this one here, notice that with this, it's in y-intercept form. Now, with y-intercept form, it's easy to see where you're going to shade the line because you only have to look at the inequality. So right here, if it's in y-intercept form, then if it's greater than or equal to, you're going to shade above the line. If it's less than or equal to, you're going to shade below the line. So one way of doing it is put it in y-intercept form and then sketch the graph, and then you know it's either going to be above or below the line. Okay, so in this case here, what do? You can use the y-intercept form to find it. So you have your slope, you have the y-intercept, which is 0. So it goes through the origin, so you can't use 0, 0 as your test point. But in this case, you don't need to because we're going to use the fact that it's in y-intercept form. And so your intercept, or your slope is going to find the next point. So it's going to go down 2 and to the right 3. So we go down 2, right 3, and there's our other point. So we draw our dotted line with the arrows. And then now they use a test point. And you can use a test point, but because it's in y-intercept form, the inequality will tell you whether it's above or below the line. In this case, it's greater than, so it's going to be everything above the line. And if you use a test point, it just confirms that that's true. Okay? And in this case, we get a true statement. And so everything on that side of the line is part of the solution. Now, what about vertical and horizontal lines? Well, these are easy because if it's a vertical line in this case, and it's greater than, because then it's going to be everything to the right. Less than is everything to the left. If it's a horizontal line, then you're going to look at everything above the line is greater than, and everything below the line is less than. Okay, so these are two special cases of where you would shade in the half plane. Again, if it's less than or equal to or greater than or equal to, you would have solid line. If it's strictly less than or strictly greater than, you would have a dashed line. And so in this case here, it says we want to graph each of these inequalities. So this is y is always, so y is less than or equal to -3. So we take y is equal to -3. And since it's equal to in here, then we're going to have a solid line. And this is going to be what? It's going to be a horizontal line because y is always going to be equal to -3 or less. So here, if we solve the equation first, right? So we're going to have a solid line at x equals -3, or excuse me, y equals -3. And now it's less than, which means we're going to shade in everything below the line. And there's a solution. Here, we have x is greater than 2. And so there's no equal sign, so this is going to be a dashed line. So we start with the equation, x equals 2, which is going to be the vertical line here. Okay. And then we look at the inequality and it's greater than, so which means it's going to be to the right. And that's how we shade it. Now, what about systems of two equations? So if we're modeling with systems of, or excuse me, two inequalities, then just as we did with a linear system of two equations make up a system of linear equations, two or more linear inequalities will make up a system of linear inequalities. And a solution of a system of linear inequalities in two variables is an ordered pair that satisfies both inequalities in the system. So very similar to when we talked about a system of equations. Now, the solution set of a system of linear inequalities in two variables is going to be a set of all ordered pairs that satisfy both inequalities, all of the inequalities in the system. Okay, so in this case here, it's going to be a region, right? A shaded region. So if we want to graph the solution for these two equations, well, the first thing we need to do is graph both of these. So we're going to use the substitution method. Okay? So the first thing we're going to do is solve for the inequalities with equal signs. So we're going to substitute in these for equal signs. So we're going to use x minus y equals 1 and 2x plus 3y equals 12. And we're going to graph these. Okay? And if we graph them, we use again, you can use the intercept method or the slope-intercept form to get these. So again, they use the intercept method to graph these. So you find the intercepts for both of them and you graph them. And so here's the graph of the first one, right? So this becomes this region here. And then you graph this line here, right? So you graph both lines. And then you can use test points. Okay? So if you graph the two lines, you've got this line and this line. And how many regions do you have to test? Well, you have this one, this one, this one, and this one, right? Well, if you use 0, 0, the origin, you can use 0, 0 in this region to test. Okay? And if this makes a true statement, then you know all of the values in this system are going to be the solution. And then you could use a test point here and here. So that's one way of doing it. Another way of doing it is to graph these with all the regions, right? And then to graph this one on top of it and shade in that region. And where the two regions intersect is the solution region. So in this case here, we have this region above this line, and then the region above this line, and where the two regions intersect is right between these two lines right here. And so the solution set is everything in this region. Okay, so there are different ways of using these. You can just plot the solution for each one, and wherever the regions intersect, that's your solution region. Or you can use test points and use a test point here, 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 and here, and and where the test point makes a true statement, that's going to be your region. Okay, and that's either way is fine. Okay, so now that ends this section. So again, please make sure you watch these videos before the class begins. Please make sure that you're working on the suggested homework for this section. Again, make sure you're also practicing. If you have any questions or if you get stuck on anything, come to class with those questions and we'll work out together. Or you can email me and we can do that too. If you email me, I can also work on those in class as well. But until then, if you have any questions, email me or I'll talk to you soon. Bye-bye.